On behalf of the Computer History Museum, this is Uday Kapoor, a volunteer here in the program to record oral histories. And with me is Doug Fairbairn, a colleague of mine. And we are welcoming Bernard J. Lacroute, a retired executive in the industry, in this computer industry, and also in the venture capital world, and recently the winemaking industry. So welcome, also known as Bernie. Welcome, Bernie. You were born in Burgundy area of France. So why don't we start with your early life?
Well, I was born in a small village, very small town. My father was in the woodworking business, and I look very fondly to those early years. It was actually wonderful. I had a great childhood. I owe a lot of my parents. There were really some fundamental values that they gave me. Don't give up, do it right, and be yourself. And that was wonderful. I mean, I hear sometimes people complaining about their parents and so forth. I had wonderful parents in childhood. So that was great.
What was the village like? I mean, was this an agricultural town?
Basically agricultural town, yes. There were about 1,000 people living there, and it was mostly agriculture, yes.
Mm-hmm. So you had no acquaintance with technology? And
none whatsoever.
What year were you born?
1943.
Okay, right.
So
in
it
the
was
middle
actually
of the war.
during the war. My parents' house was occupied by the German army during the war. I don't remember that, but I hear a story about it all the time. Yes.
So in terms of siblings, did you have
I had two sisters, and they were older than me by 16 and 13 years, and they all got into some form of not high-tech business, but my older sister was teaching mathematics in Paris, and my other sister ran a college. So they were.
So you were essentially an only child. They were so much older.
They were much older than I was. They were more like parents than sisters. Yeah.
So your father was in woodworking.
Yes.
And you mentioned something about learning a lot from that.
I did. Actually, my entire family, as far as I can trace it back, was in the woodworking business. I can go back to the French Revolution, and they were all involved in some form of woodworking. So my father did, I remember after the war, he converted some American Jeeps into cars that were used by people, and so all the frame was made out of wood rather than metal at the time. And so I remember him working on that and adjusting those pieces together, and it was quite interesting. He had a knack for understanding 3D geometry.
Was he making furniture, or was he selling what he did? Or
well, he did windows and doors, and in a small town you do just about everything.
Interesting.
Yeah.
So your schooling was in the village?
Was in the village until I was 11 years old. Then I went to boarding school because that was the way to go and get better education. So my two sisters had done the same kind of thing before. So I was shipped up to boarding school at the age of 11, and it was a very difficult thing for both my parents and me, but it was the right thing to do in terms of getting the proper education.
How far away was that? Was that quite distant?
About 60 miles. Mm. But in those days, it took a while. I would come back home every 3 weeks or so for the weekend. And the rest of the time I was there.
So you would take the bus, for example?
I would take the bus, that's right. Actually, a change bus in between. Yes, that's correct. And in those days, we actually had classes on Saturday morning. So the French system, you had Thursday afternoon off, but you had classes in Saturday mornings.
So, any subjects that interested you during the school days?
Well, so that was interesting because it was a very much of a track system. So if you started at the top of the track, you could go down, but if you started at the bottom, you could never go up. So I had 7 years of Latin, and as long as math and physics and history and geography and all of those good things that we don't seem to teach anymore these days, as well as English and German. So we had to go to 3 languages basically.
So, what year did you graduate from school?
What year did I? So that's let's say 11. So that was 54 and 8, 61.
Okay. And then you
From school, you mean from high school?
High school,
Yeah,
yes.
right. 60 or 61, I don't remember exactly. But I spent 2 years in prep school to prep for engineering school. So that's a brutal program, highly competitive, and it's mathematics and physics. 18 hours of maths a week and 14 hours of physics a week. And that's it. And if you don't make it, you don't make it. And that, yeah.
So were you always interested in math and physics? And
I was kind of interested, yeah, because my father being, really interested in geometry, that type of thing, I was saying, yeah. Yeah.
So then the next step was to look for graduate school or?
Yeah, so the way the system works, you take contests, basically. I mean, there are, I don't know, maybe 15 or so engineering schools in France at the time that were significant. So you go and try for every one of them that you can, and you have 2 to 3 years to make it. So when you're in prep school, you can try it after 2 years, and if you don't make it, you can try it another year. And then based on what you decide, you take one school or another. Given my parents' financial situations, I opted out to go to an engineering school after 2 years because that was a safe bet. I didn't want to try it again the following year. So I ended up in engineering school in Grenoble, and the director of the school was Louis Néel, who was a Nobel Prize, worked in electromagnetic field, and so I spent 3 years there and got an engineering degree in electrical engineering as well as a degree in physics.
So, and when did you decide to leave France for United States?
Well, I was given the opportunity to get a fellowship from NASA. Professor Néel was on the advisory board of NASA and had a good relationship with them. So NASA had a program at that time, and they had 6 fellowships for Europe every year, and I got one of them. So I spent a year at the University of Michigan.
This is just for people in general technical thing. It didn't imply anything of working for NASA or anything like that.
No, it was no contract to go and work for them.
So how did you choose the University of Michigan? Was that
that's what they chose for me.
That's what it was. Okay.
So I was interested in plasma physics, so that they had a big program there. So I worked there for a year or so. Then I had to go back and do my military service, which was mandatory in France at the time. I also, part of the deal is that I had to go back to France for a while. That was.
What year did you go back to France then?
So it was in 1967.
Mm-hmm. And you were there 2 years or something?
2 years, yeah, basically. Yes, I came back to the U.S. in 1969 to join Digital Equipment Corporation. And made it. Yeah.
So I read that you also work for a French aerospace company.
Yeah, I worked after my military service was a year and a half in the French Navy. And actually, I was very fortunate because I worked most of the time in a computer center. We had a big CDC 6400, and we did simulation work there. When I got out of the Navy, I looked for a job in France. So I joined the Engin Matra, which is an aerospace company. And they are well known for their, they were well known for their missiles at the time, but they did other things like telemetry for satellites and that kind of thing. I worked there for 6 months and got bored to death. I was exposed to the French mini computer, the 10010 from the C2Z, CII2. And was spending more of my time with a soldering iron trying to fix the darn thing than doing any useful computations. That was pretty boring. So I decided to go and do something else.
So what was it originally that got you interested in computers? What was your first introduction to computers?
Michigan. In Michigan, they had their own language, which looked a little bit like Fortran MAD. Michigan Algorithm Decoder, and we were using that in some of the work that we were doing in physics, because you had to use some sort of simulation and so forth. So that's where I got really involved with computers.
So you got some schooling in computer architecture?
Some, but not so much in terms of formal training, no.
Okay, but at least system design.
Yeah, system design, yes.
So then we were starting to talk about DEC.
Yes.
So how did that happen?
Well, I was looking for a job in the US, and I actually interviewed with a number of companies. And my first reaction to DEC was, no way I was ever going to work in this place. It was in the old mill in Maynard, Massachusetts. The offices were made out of plywood. And the floors were old floors, wood floors with it was wool mill, and you could still feel the stuff on the floor.
Linseed oil or whatever.
Yeah, right. And I thought, geez, I mean, that's not a place to go. It looks quite depressing.
And you were interviewing, what year was it?
1969.
69, okay.
Actually, it may have been the summer of 68, 68, 69,
whatever.
Yeah, right. And
so what turned your head?
well, after I talked to the people, I mean, that was kind of quite interesting. So, and having worked with the mini computer, the C2Z 10010, DEC tapes were really good compared to the paper tape. Were really good. So I was kind of, very interested by the people I interviewed with and the machines themselves and so forth. So, yeah.
What were the other companies that you talked to?
I talked to Honeywell. I talked to a couple of other ones that I don't remember what they were, but yeah. So, I decided to join DEC despite the old mill.
So what was your first assignment?
My first assignment was kind of to put together a database of physicists who were using the PDP-15. That didn't last very long, but that was my first assignment with DEC.
I see.
Then I got involved very quickly with the RSX-15 operating system, which was a real-time operating system. Then move on to the same type of stuff on PDP-11. I worked with Dave Cutler there for quite a while, and we built an RSX-11A, RSX-11M. So they were real-time OS for PDP-11.
So you were mainly working on operating system work, not hardware design?
Not hardware, no.
And that was, so the PDP-11 or that family was already out in the market at that time?
Not when I joined. It was the PDP-15, but shortly thereafter, the PDP-11 came about, yes. Dick Clayton was in charge of that particular program, working for Gordon Bell.
So what was your contribution to the PDP-11, like the operating system world?
Well, I did two things. I did some coding as well as putting together the business plans to make it a viable entity. Yeah.
Okay. So this is a 16-bit machine.
16-bit machine, correct.
And then you worked on the VAX,
Yes.
apparently. And how did that happen?
So when the DEC realized that it needed to go and build a new version of a computer because of the limit in the addressing space of PDP-11. I mean, it was 16-bit machine. You couldn't go beyond a certain range. So the idea was to build a 32-bit machine. And there were really competing proposals. One of them was to extend the PDP-11 architecture to try to make it look like a 32-bit machine, which I thought was a pretty dumb idea. But there were proposals to go and do that. Then there was a proposal to build a brand new 32-bit machine from scratch with a new operating system and so forth. And there were a lot of infighting at DEC at the time because the people who were making their living out of selling and marketing the PDP-11 didn't want to see another computer to go and compete with the business that they had built. So there was a lot of politics involved as to what was going to happen. And actually, the project went on for about a year and a half, maybe 2 years, debating which way to go and making no real progress about making a decision.
So were both projects underway? That is,
They were paper projects.
Paper
They were not real hardware or software, but paper project proposals and two different architectures fundamentally. Then the decision was made by, I suspect, Ken Olsen to go and create a separate team to go and build that 32-bit machine. And they needed a product manager for that. So my role was really to help the engineers define what the computer characteristics would be, what kind of software we would have, how we would target it, whether it be purely scientific machine or would have also business applications. And so I became involved in that deeply, worked closely with again, David Cutler moved into that space. And Dave Rogers, I don't know if you know Dave Rogers, he was one of the hardware guys involved in that. And Gordon Bell was very, very much involved in defining the architecture. And the reason we succeeded is that at least maybe Ken or most likely Gordon realized that unless that created a separate entity to go and make that happen, it would be hampered by the existing organizations that would try to block it and kill it at every turn. So we are set as a separate group and actually reported directly to the operating committee of the company. Although there was a structural line, we had a dotted line to the top management of the company. And that's what made it happen in somewhat record time. We did this thing in a little over 2 years. Both the hardware and the operating system.
that's quite an achievement to do.
Quite an achievement.
A whole new 32-bit operating system.
You are right. I mean, Cutler was the main guy. Dick Husfeld was the other major contributor. Dick ran into a terrific car accident a few years later and has been paralyzed ever since. It was very sad. But they were the two major.
So was this a sort of a high energy,
very
dedicated
high,
team and
very
excited?
high energy, super A team, take no prisoners, get it done, show the world what you can do. And it was not just money. It was motivated by we want to show what we can
This
do.
was the kind of pioneering project for extending the addressing modes and so on.
Right. So we threw out all the whole stuff and said, okay, let's start from scratch and go 32-bit with a possible extension to 64. And if you look at the original architecture design, it had the path to a 64-bit addressing space was absolutely there. The only regret I have with this architecture is that we didn't apply that to the I/O system. The main bus was a 32-bit bus, but the attachments were remnants of what existed for the PDP-11. And in retrospect, I think that was a mistake, because it would have been a much cleaner architecture if we had changed the bus structure for the I/O system as well.
So it seems like the focus was on complex operations and extending the orthogonal architecture.
No question, yes. And so it was a classic CIS machine. One of the decisions was made to the dismay of some of the product lines was to incorporate a bunch of instruction set which would make COBOL run very efficiently. And that turned out to be extremely useful in the future life of digital equipment, because although the machines were originally targeted towards the scientific community, it very quickly found its place in the commercial world, and
So yeah, I was going to ask about that. So you said you had a role or leadership role, perhaps, in defining what that market would be. So your original or your primary target was the engineering community, but you envisioned that it would also be sold into the business community as well.
Absolutely, it would be. We had in the team, we had absolutely no debate about we wanted to build a machine that could be used everywhere, not just the scientific community, but everywhere. Yeah, I can start with the scientific community, but it better be able to address the commercial applications, the communication applications, and all that type of stuff. So if you look at some of the instruction set, they were specifically targeted to text processing and those types of things.
Did DEC have any products in that space? Or
Oh,
were they
absolutely.
selling into
Yeah,
that
they were
space at the
selling
time?
on the PDP-11. There was an operating system called RSTS, which was a time-sharing system, which was very popular in some banking applications. And so, yeah, absolutely. But the product line who managed that segment of the business didn't want it to be upset by anything. And so.
So for the VAX, you had the VMS operating
Yes.
system. Okay.
Virtual memory system, yes.
And when did Unix enter the picture, and what was the?
Okay, so the one of the target customer. I mean, actually, it's a very good question, because there was a debate at some point whether or not to build a new operating system or use Unix. AT&T was a major customer of Digital Equipment Corporation. The labs were absolutely very large customers of DEC. So they were involved. They were be made aware of the project very early in the game. I recall one particular trip to Bell Labs where the 6 of us went down in 3 separate planes, because the company was afraid that if we're all in the same plane and we got killed, that
The project would be killed.
It would be a disaster. So we went down in 3 planes and spent a whole day with the guys at Bell Labs, because we wanted to make sure that they were going to go and buy the machines. It's nice to build a machine, but if you don't have any customers, not particularly useful. And they worked very hard to convince DEC to have Unix as the operating system. Rather than VMS. And finally the decision was made, no, we need to own our own destiny. In retrospect, they may not have been the right decision, but at the time, it was probably the right decision. The other thing that was involved in there was the networking system. DEC had actually, for the time, a fairly sophisticated networking system called DECnet. And we could incorporate into VMS some of the features that were needed to make this thing work well. Now, again, could have done something similar with Unix with TCP/IP, but in those days, controlling the whole thing, not unlike Apple, was thought to be the right thing to do. So that's where eventually the decision was made to go with the VMS. But as soon as the Bell Lab guys had a machine, they ported Unix on it. And we actually helped them port Unix on it.
So did they actually ran that as their primary operating system?
Well, it depends on which section of AT&T
Okay,
was.
so split.
Some of it was running VMS and some of it was running Unix. Yeah.
So what year did the VMS project get kicked off and they said, okay, go?
So late 75, early 76. I don't remember exactly. We shipped the first machine very late on December 1977. The entire engineering team was assembling the first machine for AT&T. And it had to be out that
December 31st, right?
31st, very late. But it left.
So what was the networking technology like at that time, and how did the Ethernet come in at that time?
Well, at that time, Ethernet was not there yet. Okay, so the Ethernet really at DEC came about in late 1980, 80, 81 or so. So the idea was, I mean, Gordon Bell really sponsored the project because, again, there was competing architectures. One of them, which was Ken Olsen's favorite, was to stick up with serial line. And then there was the token ring from IBM and Ethernet. So Gordon was really championing very hard the Ethernet technology, and got together with Xerox and Intel to go and try to make that a standard. And so I switched role in 1981 and became the manager of the networking system for DEC and the primary liaison for the Ethernet project on the DEC side. So I had the opportunity to work with Dave Liddell and Bob Noyce at Intel, he was quite a phenomenal individual. I had a really good time working with Bob. It was really...
Everybody speaks very highly of Bob Noyce.
Pardon me?
Everybody speaks very highly of Bob
Noyce.
Noyce.
Very nice man. Very smart, very nice, very good human being. So what
was the motivation, either technical or business, for DEC already had DECnet?
Yeah.
What was the key that made Ethernet an attractive option?
So that was, I think, a strike of genius, and I think it really needs to, the credit, I think, needs to go to Gordon Bell, who could see that DEC by itself could not establish a standard, if you wish, in the networking community. I mean, you were up against IBM and Token Ring as a main competitor, and DECnet by itself, although DEC was a big company at the time, it was going to be very difficult to go and counter that. And I think Gordon saw that very clearly and pushed very hard to go with, quote unquote, an industry standard which would encompass more than one company. And that was a hard-fought battle, too, because, again, DEC wanted to stay with DECnet and all that kind of stuff. So eventually the decision was made to port DECnet onto the Ethernet as well as TCP/IP. And
what about from a technical point of view? What would you say the technical advantages or things that allowed Ethernet? I mean, it had these various supporters. Xerox, big name, but not big in computing. Intel, obviously, big in chips. But
right.
So what were the sort of the key to getting that over the hill? Is it technical advantage or what?
It was more a strategic advantage. How do you counter IBM?
Mm-hmm.
How do you have something which is not going to be under the control of IBM? That was the main motivation.
So you headed the distributed systems group.
Mm-hmm.
So
that was the networking group that
Okay.
I talked about before, yes.
So how many people did you have at that time?
I don't know, 400 or something.
And sort of besides trying to get Ethernet established as a standard, what were the other responsibilities of that team? And it was
Okay,
a whole set of
DECnet,
products and
DECnet
Uh-huh.
and all the communication interfaces that went on the PDP-11 and VAXs, all the DEC machines.
so the whole communications infrastructure for all
communication,
digital.
hardware, software, yeah,
Mhm.
the whole thing, yeah.
Okay. So anything more on deck before we move to?
Well, I mean, yes. So DEC, to me, was a wonderful company. I will always remember DEC with very great fondness. They treated me very well. Very, very good company to work with. The sad part about DEC is that they just VAX was the last time where they could upset the existing business model. And after that, it just could not happen. Ken Olsen was a great man, a lot of respect for him, just couldn't change his mind and move away from the time-sharing business. That was DEC. DEC was the time-sharing company with mini computers, and that's the way the world was going. And we just could not get him off to. There were two or three obvious directions that needed to be addressed. Chips, eventually built Hudson, but it took a very long time to have the computer in the chip. Ken didn't believe in that. Then the workstation business was coming. You could see it. Apollo had been created, ex-DEC people. They were the sons of the world, mostly struggling, but you could see the direction. We actually had a Microvax running in the lab, which was a wonderful workstation, engineering workstation, but that would have upset the time-sharing business model dramatically, and there was no appetite to go and get that done. So very sad. You just could not.
It's
Couldn't
the classic where you cannibalize your existing business.
Absolutely. And
When did it become clear to you that DEC was on the wrong track? Or
certainly in 82 or something like that. There was a lot of struggling in the company at that time. I left in 83. There were a bunch of people left in 83. Cutler was one of them and a couple of other people. And we were trying very hard to go and move this thing. Could have established VAX as a standard for workstations. There's no question about it. That could have been done, the Microvax and blah, blah, blah. But no, it couldn't move out of the time-sharing business. So that's, yeah. So actually, I think, I was no longer there, but I think DEC missed another opportunity when they defined Alpha, which was a great architecture, well thought out. I can't remember the name of the architect on that. Somebody who was on the VAX team. The name is going to come back. But again, they could not put all the resources needed behind Alpha. So it was a half-assed solution between standard VAX and Alpha and this, that, and the other. And Cutler, I know I didn't propose to put NT on it and a few other things, but no, it just couldn't.
was Alpha going to run VMS or was it
Oh,
going to?
Yeah.
So it would have been a compatible operating system, just different.
Right, but I mean, at that time it was clear that you needed to move into Unix.
Yeah.
I mean,
Unix was clear by that time.
So the right thing to do, to have done, was to maintain a product line to satisfy the existing customer, but on a relatively low budget, and put the bulk of the resources on the new thing. But it's just the opposite that happened. So I kept doing the whole thing, and the new thing never could live. Same old story. Cannot capitalize the existing business. So that's very sad.
At that time, were you starting to look at other opportunities?
Yes, I did. Actually, I was, Apollo wanted to join me to join them, and a couple of other places. Motorola was trying to develop a workstation business, believe it or not. And I met with Galvin a couple of times, but they were a semiconductor company. They didn't understand systems, and there's no way that it could have worked. So.
Yeah, but Apollo would have been a natural.
It would have been
fit.
natural. But
so you eventually went to Sun. How did that all come about, and why Sun versus Apollo? And
well, so Sun had hired Brown as a president from DEC. So he rumbled my name to a couple of people, and actually Vinod called me. And so Vinod called me and convinced me to come and take a look and blah, 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 and I did.
So you came back to Sun and they twisted your arm, or?
Well, I mean, I met with the team, and primarily Bill and Andy, and Vinod and Scott, but primarily Bill and Andy, and we talked a lot about what they were doing and where they saw things going. I mean, it was just like DEC in the old days, an engineering-driven company. There's no question about that, and they had a vision of where they wanted to go, and it kind of matched where I saw the world going. So that's that.
And how did you compare Sun with Apollo at that time?
There were a couple of people at Apollo that had left DEC that I didn't particularly care for. And I thought they were marginally honest. So that, I don't think it would work for that environment. I mean, that's, again, if you don't believe what you're going to do. I mean,
and what was Sun hiring? What did they want you to do? What job?
Okay, so
what were you going to contribute and fix?
I started at Sun as VP of Engineering, and I did that for about 6 months. So Andy was kind of the de facto VP of Engineering, but he didn't want to manage people at the time. I mean, he's certainly shown that he could learn that. So it was pretty chaotic.
So there wasn't anybody that wanted the job that you displaced?
No, they were actively looking for somebody to run engineering. And so that was that.
So what was the state at Sun at that time? In terms of architecture, they were, of course, they had Intel, Motorola.
Yeah,
Spark
so
had not.
That was Motorola,
Okay.
and the multibus mostly switched to a VME a little bit later, but the original machine had the multibus I/O system, Motorola, as the microprocessor, and that was the big screens, CRT, that made a big difference. The first one that you saw was very boxy and so forth, kind of ugly, but it was better than anything else there was on the market at the time. So that was the machine.
So how what kind of role did you play in getting the Spark?
Well, I should talk a little bit about the first year or so at Sun, because it's kind of interesting.
Yes.
There were many nights where I couldn't sleep because they was really, really, really tough. They had the Sun 2 had just come out, and the Sun 2, and then it had an MTBF for maybe a few days. I sat down with Andy and said, well, let's go over the timing analysis, Andy. The what? What's that? Well, he knew what it was, but he ain't done some. So we went over the timing analysis, and it was out of sync by 10, 15 milliseconds. I mean, the reason it worked is that he had a can of Freon in the lab, and you cooled the chip. It works. Yeah. But how do you manufacture that in any kind of volume? Man, that's not going to work. So they also had made the decision to go with the 19-inch CRT, which was built by a company in the Midwest. I can't remember the name of this company. And that too had an MTBF of hours. So what happened is that the inside, the vacuum was not good enough, so there were still particles in it. And when you move the display, it would arc and zap the motherboard. So we try every single trick in the world to try to contain this arcing business until we could get a different display. And at one point, we were shipping 2 displays per machine, because if you left them on the desk and don't move them, once the dust had settled, it was fine. But if you move the thing, I mean, chaos. So by the time I had hired a guy named Howard Lee from HP, who understood analog technology a little bit better than anybody else. And one day they figured out by putting a FET transistor on the neck of the neck board of the CRT, we could actually contain the arcing. Nobody understood the theory behind it, but by trial and error, it worked. So that was a big improvement. We had a better MTBF. And in the meantime, we redesigned the Sun 2 to have better timing tolerance so that it could...
So you really had to redesign all the logic.
Absolutely. Yeah, it was off. I mean, there's no way.
So you were building your team.
Building the team, yes, absolutely.
So
hiring people as fast as you could, and engineers who... I mean, Handy was an incredible designer, but, you know, well, I'll give you another trick then that we played, and this one on purpose. For the 68020, the standard 68020 run at 16 megahertz. And that forced a wait state to be introduced in the memory system. It was just that missing. And so we wanted to be faster than the other guys. Then Apollo and so forth said, how do we beat that? Now we made a conscious decision to go and sort the chips at Motorola with Motorola's agreement. So we were shipped 68020 with a little green dot on it. So the chip was off maybe at 16.5 or 17 megahertz by sorting, avoid the wait state. So the Apollo guy said, well, you can never make it work. I mean, it's going to fail. So they blobbed to all the companies that would not work. Well, it did work. And this time it worked because we knew why it would work. The timing analysis had been done, and we sorted the chips, and it worked. So that was a part of the...
So how did you build the team? What kind of people were you hiring? My main criteria was what we will refer to at Sun as brain power. Get smart people. There is no replacement for smart people. Yes, we need a few guys like the Howard Lees who have been around the block and can help bring the structure, but get smart people. Guys who didn't know it couldn't be done, who were very, very smart and could say, okay, we are going to do it. So that was the main criteria. So, for example, you hired Eric Schmidt and Wayne
No,
Rosing.
Eric was here when I came.
He was there?
He had been there for maybe 3 months or so. So Eric was there. He had come out of Berkeley, and he was there. And He was a very, very smart guy, but I mean, there was no management experience in the team when I came. Really, none.
So was the first year mainly devoted to getting the Sun 2 stable and shippable and reliable?
And get started on the Sun 3 and so forth. I mean, my philosophy had always been you have at least two generations going at the time. And so we did that successfully with VAX and PDP-11. So, I mean, there is the main project and the one that starts right behind, so that when the first one is finished, you can put the second one in high gear and be ready for the next generation. I mean, Gordon Bell had this motto, time to market, which was really, how quickly can you get it done and get those things. And I added one, which was time to money, because time to market is good, but if you don't make any money to do with it, then that's, yeah.
So at some point, the decision was made to go for Spark.
Right. So a lot of discussion took place with Motorola on what was the future of the 6800 architecture. And they talked to us about 68030 and so forth, and we couldn't see how we could get enough power out of those things. Motorola had not started their own RISC program at the time, and so it was standard Motorola stuff, 68020, 68030, basically being driven by semiconductor technology rather than architecture. And what's the differentiation with the Apple of the world and any of those other guys? So the decision was, well, actually, Vinod was probably the most instrumental in making that decision to go and launch the Spark program. So that was the end. That much I remember clearly. It was the end of 1984, and we had just finished the year at maybe, $4 million revenue. And when we went to the board and say, well, we would like to build our own microprocessor, they almost threw us out of the room and said, you guys, you're nuts. You can barely make 68,000 work properly. What the heck do you think you're going to do? And finally, we convinced them that, it was the right thing to do. And so here it went.
Whose idea was it originally? Who sort of sparked the idea?
I think it was Vinod. Mm-hmm. I think it was Vinod. I mean, Bill got involved in it very, very quickly, but I think the original guy was Vinod. Yeah, I'm pretty sure.
And the vision was to do a RISC processor based on the research that had been done at Stanford and Berkeley. Was that the idea?
Well, there was a strong connection with Berkeley because of the Bill and Dave Patterson. I had worked with Patterson myself at DEC. He was involved in some of the architecture on the VAX system and VLSI and so forth. So there was kind of an affinity towards Berkeley, Unix, and that kind of stuff. I think it was not hard-cut choice that, it would be Berkeley versus Stanford, but so there was an affinity.
But they were, that was the idea. It was using that. The RISC idea was the fundamental starting
Absolutely.
point.
The RISC idea was the fundamental. Yes, that was the basic idea. Build a machine and make it go as fast as you possibly could. Reduce the instruction set as totally and make it run.
So coming from a CISC background as you did from digital equipment, how did that strike you? When did you see that RISC was a viable path to go?
Well, we had certainly studied what IBM was doing. They had a RISC program. Also talked to a lot of people in the industry and the research community, and it looked like a good thing to do. The other thing, from a practical viewpoint, there was no way, I think, that Sun could have implemented a CISC machine, which just didn't have the resources, the talent necessary to go and do that. So there was the practical aspect of it, which is, at some point you've got to go and do what you can do, and not just what you may be dreaming of.
With all the work for operating system and compilers. And, yeah.
Yep.
So the motivation was performance. You were not going to get performance out of
Out of
Motorola Path.
Could not see.
And so what was, when you went to the board, what performance gain did you forecast?
I wanted a factor of 10. If we don't get an order of magnitude, it's not worth it. And when the first machine came out and it was running at 4 times the performance, I said, I'm going to can this darn thing because it's not good enough. So that's when the operating system guys came into play and tuned the heck out of it. So we got about, when the first machine came, about maybe 5.5, 6 times the performance of the Motorola machine. But we didn't make the 10 times, but that was the goal.
You got to start with 10 to make sure that you get something worthwhile,
Yeah, right. I mean, if it's 2 times more performance, not that interesting. I mean, you got to make enough of an impact that it's yeah.
So what role did Bob Garrow and Wayne Rosing and those people play in that?
Well, Garrow came later in the game. So Wayne came earlier enough in the program and was very much involved in the risk project, managing a big piece of engineering. Don't remember if he and Howard were on the same level or what. Eventually, Wayne managed all the hardware side, but Howard might have. I'm pretty sure that actually Howard managed the 68,000 projects, and Wayne originally was involved with the risk project. Yes.
Right, I know, because he was like my counterpart when we at Cypress were working with Sun.
Right. No, that's
but
right.
he was reporting to Bob Garrow at that time, from what I remember. But maybe not.
Which year was that?
This was like 1984, 85.
No, Wayne didn't report to Garrow. He reported to me. Yeah, no. He may have after I left, but it was not.
Because we had some issues to resolve, and Bob was always there to help out.
Okay, well that's maybe so, but no, Garrow was in the manufacturing side, and he was, Wayne didn't work for him at all at the time. No, that's right.
So was the Spark project, was this a huge project? Was just a couple of people working on that? What was the
It
nature
started
of
with
that?
a small team, about 15 people or so. And again, the motto was brain power, get the best you can, and get it going. So a very, very small team to start with. And that's one of the lessons I had learned from Gordon Bell. Don't overstaff, don't overfund, just get smart people and leave them alone and do so.
And what about the impact on the operating system? How big a job was it to port the operating system?
Significant job. The Dave Shannons of the world really did very, very good job porting this. Rewriting the compiler, C compiler. I mean, most of the operating system was in C, and there was a few sections that were in assembly language, but most in C. So the first job was to rewrite the C compiler. So it was a big job, big job.
And how did that project go in terms of time frame, cost, and so forth, versus what your plans were?
Time frame, we were maybe less than a year late, 6-9 months maybe, not bad. Money-wise, it was not too bad either. I mean, we spent a fair bit of money, but not really outrageous.
What was the total time of the project from kickoff
to? We made the decision was made at the end of '84. The first machine shipped in 1987, June or July of 1987.
And what was the state of Sun at that time? Were you still doing well? Was that necessary to kind of kick things up a bit, or what was the?
Well, I mean, once the redesign of the machine had been done, the Sun was starting to get in shape, starting to make money again. Although we, again, very dicey in late 93, late 83, 84, we're almost out of money. I mean, it's just, a customer didn't pay because the machine didn't work. So, but the income, the cash flow started getting better. We got some more money from the venture guys. Mark Wart and John Doerr were on the board, and we got some more money. So things had started to shape up. I mean, it looked like there was a big marketing push, which was, standardization, Unix is the way to go, and Ethernet is the way to go. And if you don't have a open architecture, you're at the mercy of the company that you are buying from. Some of that was real, and some of that was BS, but it was good marketing BS. I mean, it really stuck in the mind of companies. So companies started getting, back on its feet and making money and making inroads with the customers. So, and certainly the best marketing person that we had at Sun was Bill Joy. I mean, he could sell anything. I mean,
and you also had a good chip strategy in terms of working with multiple vendors.
Oh, absolutely. So that's yeah.
And what was the acceptance of the customer base to this new architecture, new chip architecture?
Okay, before I get to that, I want to say a few words about manufacturing of the first RISC machine, because that was an exercise in frustration. So we had pretty much decided to go with the gate array because the first, building a chip from scratch, we just didn't have the expertise to go and do that. So we went to all the American manufacturers that we could think of, see if they would build the thing for us. And they all told us to get lost, and we were crazy. A bunch of idiots that would never work. You're going to go out of business. And I was unanimous, from Motorola to Intel to whoever. So, no, forget it. Get lost. TI. So we ended up in Japan with Fujitsu. The vice chairman was Dr. Yasafuku, a wonderful man that Bill had met, and I had met him at DEC because he had done some work at Stanford, and he was selling memory to DEC. And so we went to Japan, say, well, we got to go and try that. And we met with Yasafuku and his team. And although the Japanese have the reputation of being very slow at making decisions, the man made a decision within 2 weeks. He said, yep, we're going to do it. Here's the technology, CK22, and we're going to work with you and make a triple-ported memory so we can have the video system coming out of it and so forth. And here we went. So after that, when the first machine came about, Sun got a lot of shit from the industry. You are selling out to the Japanese. Well, we didn't have any choice. It was that or, So I will always have recognized the contribution that somebody like Yasafuku made to the success of Sun, because we couldn't have made it. Nobody wanted to build this thing. Now, after the first machine, it was a different story. There were lots of people who wanted to build the chip. But whether it be TI or TJ or even Intel, we had discussion with Intel, blah, blah, blah. So that was a different story. But with the first machine, nobody wanted to touch it. So.
And this is a new process and a new chip for Fujitsu, is that right?
Yes, new process. The CK22 gate array had not been released, and it was tweaked to go and meet our needs. So that's sorry.
So when you said the manufacturing of the first Spark machine, was that mainly associated with the chip, or were there other challenges associated with the manufacturing process?
Well, I mean, the other manufacturing, the other manufacturing was pretty standard. We knew how to build a VME board and that kind of stuff. I mean, use WATEC chips as the floating point processor. So, nothing. I mean, you know, some challenges, but nothing that could not be mastered. And Sun had the way of doing that by then. We had put CAD tools in place, and that was a big thing that I had to push for. Put CAD tools in place so we don't have to go and do that by hand and
In
do
some
it.
sense, I played a role in that too.
Yeah, right. I mean,
Yeah.
it's
The Cypress relationship. and
absolutely, and you know, the various simulation tools and so forth. Put that in place, then that made a big
In
difference.
fact, Verilog played a big role in
Absolutely, Verilog played a big role into that. Yes, that's correct.
So I wanted to go back. You said when you were originally hired, you were hired as VP of Engineering, but then your responsibilities expanded, or tell us about that.
So when we had those manufacturing issues with the CRTs and so forth, there was a guy from Intel, name is going to come back to me, who was actually a very good guy, who was running manufacturing. But he was fighting engineering every turn of the day. I mean, it was constant fighting. He finally said, look, guys, I mean, that cannot continue. I mean, we've got to work together. I mean, I had the engineers on the floor working out some of the problems and so forth, but we had constant conflicts. You got to go and fix that. So you let me manage manufacturing, which I had done some at DEC with the network stuff and so forth. Otherwise, you know, it's going to be chaos. So manufacturing, and I had a strong background in understanding the business side of the stuff. So let's put all the product stuff basically together, which makes a great deal of sense. So you can minimize the conflicts between marketing, engineering, and manufacturing, and get that done. And so and I was accused at Sun to favor engineering, and I did. and I make no qualms about it. I mean, I think in a tech company, engineering is key. I mean, look at the dot-coms. Marketing doesn't pay. I mean, gets you bank. I mean, you have to have good marketing. Don't read me wrong. But
You
if
have
you
to have
don't,
good manufacturing.
if you don't have the product to start with, that's not going to work.
So you were working closely with Scott. And,
Oh yeah,
and
very much so.
How
yeah.
was that relationship?
Well, I mean, it was very good for a very long time. I think we understood where we were going and the common goals and how to grow the company, and there were lots of challenges. One of the big challenge was getting enough cash, because in those days there was no contract manufacturing, so we owned the inventory. And we were pushing technology, so we were always getting the fastest part and so forth. Well, guess what? You buy the fastest part today at a premium. I mean, 6 months later, the price is down. So if you sit with an inventory there, so we're burning cash. That was a big issue. That's where AT&T came into play and injected $250 million in the company. To go and help us fund this puppy, because it was tough to go and get enough money. So anyway, getting back to the relationship with Scott, I mean, for quite a few years it was very good. I mean, we really saw the things going in the same direction, and so I think we always did see it going in the same direction. But I have a lot of respect for Scott. But when he started pissing off on the industry, it really irritated the crap out of me. I mean, you know, there was one event where there were 3 fire hydrants on the stage. One was called HP, one was called IBM, the other one was Microsoft, and he brought his dog to pee on them. I mean, I don't know. I came from a different background. So eventually it really got me pretty irritated, and I was very tired because I was working my ass off and so forth, and said, not worth it. It's just, let's move on.
So how long did you stay at Sun?
6 years.
And so you left in
89.
89.
Yeah.
So what was the progression? Take us sort of through the major steps after you got the Spark station out, and then eventually Sun became a much more sort of enterprise level company.
Oh, very much so, yeah. So again, there was an interesting level of discussion there. There were two schools of thoughts. There were the desktop people and the server people. And originally, Sun wanted to be a desktop company, really even compete with Microsoft and Intel and Apple. But we didn't understand the user interface well enough. I mean, it was designed by engineers for engineers more than a Steve Jobs thing designing for the consumer, okay? So there was this dichotomy, do we go more towards servers or more towards desktop? And eventually Sun moved in the right direction, in my opinion, which was the focus on the servers and desktop on the desk, right, but have a big networking and server stuff on the background. So that's where it evolved, and I think it was the right thing to do, the right evolution.
That's where the growth of the company.
What?
The growth of the company.
Yeah,
happened
absolutely.
because of that.
That really, because those are very complex engineering problems. I mean, the engineering department at Sun at the time was very, very strong. A lot of very talented people who could build complex systems, which not too many people could do in the industry. And so that was a strength, and also the software guys, because they really understood networking and Unix and that all that stuff. And so it made good sense for Sun to move into that space. Yes.
So,
And were you part of that decision? Was that a major decision to move into the sort of
It was an
focus on-
evolution more than a formal decision. More, it evolved into that. Yes.
So what was Sun's business when you left? What were the major
we had
product
just finished $2 billion.
And that was coming from combination of servers and desktop, or was
Yep.
it mainly servers at the time? Or?
Well, it was a combination of both. I don't recall the exact ratio, but it was both.
Desktop was still significant at that
It was
time.
still significant. I think it was. I mean, if you look at the revenue itself, I don't remember, but what I remember clearly, the profit margin was coming more out of the servers, because we had made some really. I remember one of the marketing decisions was made. Two of them I'll relate to. One was the the Sun 50, I guess, 150 that came. Yeah, Sun 350, I guess. And that was a desktop machine, and Apollo was priced at about $5,000 for a comparable machine, and we were still trying to attract applications to go and move to the Sun. It was maybe 85 or something like that, or late 84, 85. And so there was a big debate as to what we should price this thing at. And so there was the classic marketing proponents say, well, we have to have 50% gross margin and blah, 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 blah. And the other side of the proponent certainly was one of them, and so was Bill, say, no, we've got to get market share. We don't want to lose money in those things, but we've got to get 3,500. And that made a big splash in the industry. Say, wow, look at that. So how could you not buy this stuff? I mean, $3,500 versus $5,000 for Apollo? Yeah, here we go. So we attracted a lot of attention and applications being ported to the platform. So that was one key marketing decision, and Bill was instrumental in that. I mean, I remember Bill and I argued to death with a lot of other people for doing this kind of thing, which was disruptive, but that made sense. The other significant strategic decision was made when the first Swiss machine was introduced. So we were 5-6 times faster than the other guys on the block. So we should price higher, a lot higher. No. We are going to price 10% under. And again, guess what? You have a machine that is much faster. It's less money than the other guy. Come on, go and buy it. And that's really took off. I mean, you have a compelling argument. My view in this world is you never want to lose money. Losing money is stupid. I mean, it makes no sense.
And the other strength was the reliability.
Yes. But if you can make it easy to sell, or actually, the fundamental stuff is you don't want to sell. You want people to buy from you, and make it attractive enough so they can buy. And so the Joe
pull from the customer.
Well, yeah, the Joe Roebucks of the world, he loved it. I mean, man, that's yeah. Sorry.
So was there, when you decided to leave, what were kind of the things that came together? Was it pulling from something else, tired?
I was tired. I was exhausted. And there was something which I thought was totally stupid, which is to change the inventory system on the last months of the fiscal year. I mean, come on, you just don't do that. You wait until the next fiscal year. So for 3 weeks, Sun couldn't take orders. Because you know what it takes to switch a database and so forth. So you guys, that's crazy. So anyway, but I was exhausted.
So was there a pull also? Was there an opportunity, or you just said, I just need to get out?
I need to get out. I'm tired. That's it. No, I had nothing lined up. There was no. I took some time off because I just needed to get some time off.
This is 1989.
Yes, 1989. Yeah.
So what were you thinking then after that?
I was not thinking. I said, let's go and take some time off, spend some time with the kids, and not do anything for a while. So that's that.
And how did the next step evolve?
The next step, I mean, I had a lot of calls and so forth. I mean, I met with a bunch of people, and John Doerr was on the board, and Sequoia guys. I knew Pierre Lemond pretty well, and a few other things. And I spent some time with all of them. Larry Ellison, and Larry was enamored with the hardware already at the time. It was
he was already taking a look. Huh?
It was a different machine. Oh no! It was a completely different machine. I can't remember the name of the architecture of this thing. Yeah, I could never have worked for Larry anyway. So that's the other one that would not have worked for me. But
so how long did it take you to settle on something?
Maybe 6 months or so. Yeah.
So you decided on Kleiner Perkins.
Yeah.
And, so you were thinking of investing in areas that you really liked?
Yeah, I mean, what was attractive to me is that I could stay involved in technology, which I enjoyed. I really enjoyed technology, but also being involved with very bright people. I mean, both at DEC and Sun, I was working with smart people. People were much smarter than me, but I enjoyed working with them because of the stimulation. You could throw ideas, you could argue, you could debate and come up with a better answer and so forth. That, to me, was really, really an important part of whatever I was going to do next. And some of those entrepreneurs are really, really, really smart. I mean, they force you to think out of the box, and have different ideas and do things that have not been done. And so that was very attractive to me. That part I really enjoy.
So a classic problem operating people moving into venture capital is you can advise, but you can't tell them what to do. And
it was hard, no question. I enjoyed my time in the venture world, but I enjoy the operating role better than the venture world. I mean, there's nothing right, wrong, or indifferent. That's me. I much rather get involved in things.
So I interviewed, about HAL computer.
Pardon me?
About the HAL computer.
Oh, yes.
Did you play a role in that?
Well, I mean, I spoke with Heller, who was kind of sitting in a maybe advisory, I don't know, a totally informal way at KP at the time. And I tried to hire Andy at Sun because he has incredible brain. Is impossible to manage, but is very smart. Heller is very, very smart, and he understood semiconductor technology very well. So I kicked the idea around with Andy to go and start a company, and at the end, I could not do that to Sun. There is no way I could have done that. So that's that.
This is while you were at KP at Kleiner Perkins.
Yeah, I was at KP. Yes, I joined KP at the time. Yes. Yeah.
So, what were the 2 or 3 investments that you led at Kleiner Perkins that you felt happiest about, proudest of, or that you?
Well, one of them was in the manufacturing space. That was Flextronics International, which Sequoia and Kleiner Perkins were the 2 investors in the company. We bought the company for $12 million and rebuilt it to be at some point the largest manufacturing company in the business until the 2 Chinese companies got merged and so forth. But that was fun. That was good. It was not straight engineering, but people made a big difference. We hired this guy, Michael Marks, as the CEO. He's an incredibly good guy who understood business and strategy and technical aspect of it. And I had a really good time working with Mike Morris. I mean, we worked well together, and I did that.
So your experience at Sun informed your vision about what this company could do?
Yes. No doubt. Yes. You see, contract manufacturing was just starting again to go and become significant. And you could see the trend where lots of companies would not manufacture themselves anymore. They would subcontract to go and to companies like Flextronics and so forth. And so that was kind of, where you bet the stuff.
Same as Fabless.
Same idea.
Yeah.
Another one which was a lot of fun, much smaller company, but was really a lot of fun, was Tivoli System, which was a network management company out of Austin, Texas. KP actually made a lot of money on the company. We built it up from scratch. There was another venture firm, Austin Venture, which we worked with on this one, and took the company public. Very, very successful. Then IBM came and said, we'd like to buy it. I say, yeah, for the right price. And they had the right price, so we got out of this thing. So those 2 that come to mind. But I was involved with a bunch of other things, not as directly, but the way KP worked in those days, I don't know what it is today, is that there was a primary person responsible for the company, but various partners would go on the board and work with the primary person to bring the right level of expertise to the company. So, I mean, Juniper Network was an example of that, where Pradeep is somebody who worked at Sun and so forth. So I got involved in a bunch of other ones. But those are the two.
Right. So how long were you at KP?
Let's see, 89, and I stopped making investments in late 1990 or maybe 2000. So I stayed on boards after that. I mean, when you start or is responsible for a company, you finish it up. But I stopped making investments in late 90s or 2000, right when the dot-com crashed.
Before?
Yeah, before. I had one that crashed, but none of the other ones.
Did you see it coming?
Yes and no. I mean, it was like the housing market. You know it's not sustainable. I mean, you have no revenue, you have no product, and you go public with a valuation of the time of 200, 300 million. That's crazy. I mean, it cannot last. I mean, it defies the laws of physics. I mean, yes, you could
But it was going to go for some period of time.
Oh, yeah, it was fun. I mean, you know, so. But one of the things at KP, which was not a negative one in a sense, so KP had been involved with pen computing, like Go and so forth. And we tried to claim, so I ended up working on cleaning that mess up. That was not a fun thing to do, to go and clean it up and get AT&T involved to bail us out. I mean, that's the dirty part of the venture business, when you have to clean that up. And so John was involved with Go at the beginning and so forth. And when I got there, I mean, eventually they asked me to come and clean it up, which I did, but I didn't enjoy it. It was not fun.
How did you find working with the other venture firms? Was it very competitive? Was it collaborative? Was it?
Yes, to both, competitive and once, you see, very, very competitive to get a deal. But once, let's say, a deal was made, I mean, we had common interest. And so I work with a bunch of people. I mean, Kramlik and Moritz and a bunch of other guys. And I could work well with most of those people. I mean, very, very few exceptions. It could be cutthroat to get the deal. But afterwards, I think quite good. Quite good.
So you were looking at retiring from that as well, and then looking at your winery.
Yeah.
So can you tell us a little
so
bit
I
about
phased
this?
into the winery gradually. I bought land, started planting, and spent most of my time in the valley. Then eventually
The Willamette Valley.
No, Silicon Valley.
Silicon Valley.
I still lived in Menlo Park for quite a while, where I had started the winery until we got some production and so forth, and didn't move permanently to Oregon until late 1990s. I mean, yeah.
So what made you choose Oregon, and what compelled you? You know, what you must have had a passion about getting into wine. Tell me about where that came from.
I was born in Burgundy region, so wine was something which was natural for me. I enjoy growing things. Really, I have a big garden now in Napa. I've always been gardening and so forth. So growing grapes and making Pinot Noir, which was the hallmark of Burgundy, was something that was interesting.
So, even though your father or family wasn't in the wine business,
Right.
did you kind of understand the business sort of at a gut level or anything?
No.
It's just,
No.
You were just around it. It was
It's just interesting. I mean, we had wine every day, and I tell the story about my grandfather, my mother's father. For breakfast every day, he had a bowl of wine with 2 or 3 cubes of sugar and would dunk bread into it. So he lived to be 86, and it was, a long time ago. So yeah, it's so I, something that I enjoyed, and It was kind of interesting to start another thing from scratch. I bought the land, planted and built the winery, and spent a lot of time researching what to do and how to do it.
So this was bare land. There was no wine, no winery, no nothing.
No nothing.
And you chose that because it was good Pinot Noir
Yes,
territory, and that's what you had grown
absolutely, yes. That's I think if you want to make a Pinot Noir in the style of Burgundy, Oregon is the place. California makes a different style of Pinot Noir. I'm not saying it's bad, but it's different. So I was more attracted to making something similar to what's done in Burgundy.
Is that because of the weather, the soil?
Yeah, it's the weather. It's climatic conditions, fundamentally the climatic conditions. But I had looked at, there are a few other places that make good Pinot Noir, Burgundy being one of them. But I didn't want to go back to France because there are too many rules and regulations on how you can grow things. You cannot irrigate and a bunch of other things. Otherwise, you lose your appellation d'origine contrôlée, which means your wine is 1/3 of the value of the guys next door. So I was not going to put up with this stuff. The other place was interesting to me was New Zealand. They are Central Otago is a beautiful place, but it's a little far. So settled in Oregon.
And how much land did you have?
420 acres. So.
And did you make all your wine from your own grapes? Did you buy grapes from others?
No, didn't buy grapes. Didn't sell grapes.
It's all self-contained.
All self-contained. The old French way. You go and from the grapes to the bottle.
So besides the winemaking and wine growing, were you at that time looking at any other investments that you wanted to make? Okay.
No, when I decided to, that's a philosophy that I believe in very strongly. You are in or you are out. You are not halfway. I mean, it works for some people. It would not work for me. I mean, you are committed or you get out. I mean, in my career, I've seen. CEO who retired but stay on the board and went to micromanage the new CEO. No, if you're done, you're done. Get out. Go and do something else. I mean, or if you are going to be in, well, you'll be in. That's it. So, no.
So since you've left the winemaking, have you been looking at some other investments?
No.
And
no, I'm not
other
doing
passions of
not doing investment. I enjoy what I'm doing now. I have a large garden. I cycle, I ski, I travel, and I tinker with my Citroens. I've got 4 of them from 1937 to 1970, and that.
Do they all run?
Oh yes, I drive them regularly.
What I remember was that you have to lift the window up with my hand.
Yep. Yeah, you do. So so that's fun. So and I do some woodworking things. I mean,
going back to your winery in Oregon, was that people talk about how difficult it is to make money in that business. Were you able to
that is true.
Make it profitable?
Absolutely. I mean, my goal was never to make a tremendous amount of money, but not to lose money either. So we always made money. And I reinvested a lot of the money we made into people. Like, for instance, I had health benefit for my vineyard workers, which was quite uncommon at the time, but we could afford to do that. I didn't need to make a fortune in the winery, but not lose money. I mean, I always tell people there is an infinite amount of difference between a company that makes a buck and a company that loses a buck. The mindset is totally different. And that I would not tolerate. Losing money is not something that I would do.
It's a tough business.
It is a tough business. So you know what I did, which was very helpful. At the time, the selling direct was not nearly as common as it is today. But half of my business, my revenue, came from selling direct.
To restaurants or
stores?
To
people who came to the tasting room or our Cellar Club program, where we ship regularly, so many bottles a year to the customers. Yeah. So half of the revenue came from that, a much better margin, and also much more enjoyable. Yeah. I didn't like the distribution business. I mean, it's It's totally fragmented in the U.S. because of that comes from prohibition. And the reason it's fragmented is that the distributors have a monopoly, so they want to avoid wineries selling directly to shops or restaurants. Within California, you can do it, but try to sell direct to a restaurant in New York from a winery, you can't. It's illegal. Eventually, that will be turned down, just like for consumers. We had a very similar problem selling to consumers through all the states in the U.S., and finally it got turned down by the Supreme Court. So you are violating the interstate commerce laws, and eventually I think the same thing will happen with the distribution business. But they are well funded. Fortunately, we've got people like the Costco's of the world who are getting in that business, and they have the resources to go and push it to the Supreme Court.
So was the wine distributed throughout the United States?
Yeah.
But
Yeah.
worldwide, or?
Well, we did a little bit of sales in Japan and South Korea. And we had just started a little bit in China, which is a very difficult business, but, you know.
But it was served in White House and so on. So
Pardon me?
it was served in the White House.
Oh yeah, absolutely, yes. No, we built a good brand recognition, no doubt.
How did that come about? I mean, how do you get into the White House? Is that through connections or?
No, actually, they I don't know if it's still the case, but they had a good program. Their wine buyer, which had worked for, I don't know, 4 or 5 different administrations, came and visited a bunch of U.S. wineries, both in Oregon and California, and if he liked something, he just
That
bought
was it.
That was that. So it was, the guy was a very good guy. I enjoyed meeting him, and you know.
So I read that you have a passion to invest in some fundamental research.
Yeah.
Can you say a few words about that?
Well, I think fundamental research is maybe underfunded, so I'm very interested in seeing that some of those programs which may not provide an immediate return can be funded, and some of them are not going to work. I mean, that's what it's all about. It's like venture capital. Some of it works, some of it doesn't work. But we have to continue to provide resources to fundamental stuff. I've been involved mostly on the health side. I noticed you had the name Eric Gould from OHSU, which is doing fundamental research on brain connectivity of neurons and so forth, and how it applies to people who have mental disorders. So that's good. I've been involved quite heavily with Dr. Gary Steinberg at Stanford, the neuroscience surgeon. Actually, if you haven't seen that, go and see his VR lab. It's pretty amazing, where they can actually visualize the inside of the brain, and before they do surgery, they take a combination of various MRIs and other scans, combine that, and they can see and have the surgeon research where the tumors may be and so forth before they operate. They also use that as a teaching tools. Pretty amazing stuff. So yeah, I'm interested in those things, yes.
How did you get connected into that? Was it something you went
Steinberg
off to look into,
he saved my former wife's life. So I had a business plan for him and told him that I wanted to see a brain transplant in my lifetime, and they are pretty close. They are pretty close. They've done it on mice.
That's a scary thought.
No, I mean, I've got to graft all those guys in Washington. All of them.
Who is that person once they have the brain of someone else?
Well, you know, maybe we can figure out whose brain we want to put in there. So,
what about Dr. Gou's work in
So
Oregon?
that's the one who is doing research on the neuron connectivity and how it can help mental disease and so forth. Yeah.
Any words of advice for people that are starting a career or any other?
Yeah, that's what I was saying before. I mean, sometimes people ask me that question. I say, if you are not passionate about it, forget it. Passion, 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 and you can overcome many obstacles if you are driven. Oh, that's the other word I could use instead of passion. Driven. That's part of it. Yeah, that's what it is. What's the name? The quarterback of the Patriots, Tom Brady. So I don't. He graduated from University of Michigan, and I was visiting a University of Michigan a long time ago, maybe 15 years or whatever. It's just about graduating, and they said, would I meet with him? Because he was not sure what he was going to do, whether or not he wanted to go and continue in grad school or go in the football business. And said, Tom, where is your heart? Where is your passion? What really drives you? What pushes you? And that's what you should do. I cannot tell you to go to law school or whatever or do the quarterback. It's in your head. But if you have the passion for doing it, that's what you should do. Right? It's been pretty successful.
Pretty clear what the choice was.
Well, I mean, but I think I really believe in that.
Anything else you'd like to conclude with?
Well, you guys are doing good work, so keep computing, and we'll be in business tomorrow.
All right, great. Thank you very much.
You're
Appreciate
quite
your
welcome.
Thank
spending
you.
some time with us.
All right, good.